notice in my case they put a little 1 after it, so I'm going to put that universal bank data. I'm in day 7, by the way. Put universal bank data CSV on my desktop. Just check here. Let's see, you don't need to see the quiz for tomorrow yet. Let's see, let me just check. Yeah, so here it is. I'm going to check my name. I'm going to get rid of those parentheses 1. Okay. And real quick, I'm just going to talk about the data set to make sure we have a little bit of context. Yeah.
Can we decrease the light?
Yes, yes. Can you see if those switches by Jacob or
it's behind you.
Okay.
I can try and listen.
You doing?
No. Oh.
All right.
All right.
Is that better?
That's better.
Okay.
Sucks.
Ahmed, you tell me about that bouncing ball.
Sorry, sir?
All right. Let's see. Yeah, it's better to move up anyway.
In the corner or something.
Sit by Raphael.
Yes.
Go sit over there because you won't go sit this screen. You can see all the way over there.
What is this?
We can even push this table this way if you want.
No. I'm okay.
Yes, that's good.
I'm good.
No, slide over.
He has to do it like that.
It's not letting me download.
All right, so here's the data itself, and there's a tab in the Excel file that tells you the description. So the description of the variables. So the first variable is just the customer ID number. The second one's the customer's age. Then their experience and number of years of work. Then their income. Then their family size. Then their average spending per month on their credit card. And their education level. One thing I'll say about their education level is there's actually 3 variables. Education is either 1, 2, or 3. And remember, when you have a qualitative variable that has 3 levels, you only need 2 indicators. So education -1 is the observation has a 1 where that person is undergrad education. And education level 2 is a 1 there where that person has a graduate education. And education level 3, of course, we don't need because we only need 2 indicator variables to represent 3 classes, like we talked about last time. All right? Value of house mortgage held by bank in thousands. And then there's some indicator variables that say, does the customer have a securities account or not? Does the customer have a CD account or not? Does the customer have internet banking or not? Does the customer use a credit card issued by the bank or not? Finally, we have the Y variable. Did the customer accept the personal loan offer or not? So those are the variables. And we'll come back to these if we need them. Right? So again, you've now downloaded the CSV file and you should have it on your desktop somewhere. Here's where I have it. By the way, this is a rock off of California, I think, called, I don't know, it's at a place called Morro Bay. It's called Morro Rock, I think, or something.
It's way around in there.
I think. If not, it's off of Oregon, because there's places in Oregon that do that. All right, so I'm going to open R. You'll see my R's got all sorts of crap going on. Remember, the easiest way to do this is have your, RStudio. Have your RStudio open. The lower left window is just full of a bunch of text. You can Control L to clear the console. So Control L. Let me write that down. If it gets too busy or too much, you can always clear the console with Control L. The upper left-hand window is where we're going to write. We're going to use the script that I already have pre-written for you. So this is what I'm going to do is I'm going to do File, New File, RScript, and it's going to give me another tab up here with a blank window with the RScript. You can do this various ways, all right? You might not even need to do that. So if you go back here, the R code is already here. It's already written. It's called Classification Work Class 6. because I was hoping to get to this last class, so that's why it's called class 6 and this is class 7. So if I click on that, it downloads it. If I click on the download, it actually opens it right into R. So it knows, because it was a .r file, to open it right into RStudio. All right, so you remember the key thing is to run any command in the upper left-hand window, the scripting window, you need to hit Control-Enter, not just Enter. Right?
So say that again.
To run any command in the upper left-hand window, it's Control-Enter, not just Enter. Okay?
Run a command.
Right, if you want to run a command down here, like 1 plus 1 plus 1, right, you just hit Enter and it runs, right? But up here, I'll do it on line 4. If I want to run 1 plus 1 up here, right, 1 plus 2, I got to hit Control-Enter to run that command, all right? So it's just the way it works, all right? Anything in this upper left-hand window. By the way, any row up here that has this pound sign as the first character is just a comment, okay? So that's the comment character. R doesn't worry about it. It's got a comment in there. All right, so remember the first thing you got to do is get the data in, all right? The menu path is set up for me, not for you, okay? So you got to fix this so that it works for you, okay? Remember the little fight we had with this the first day, last Saturday? Okay? So I just highlighted and ran those 2 rows. I've done this a lot, so you need to remember what menu path you used before to get your data in. I'll give you a couple seconds to do that.
So we can keep the universal bank data thing, but before the slash.
Yeah, you need to figure out what that path is.
And we keep the quotation marks in there. Should there be a slash at the front? Like, could I have users?
Yeah, you could. It's just a slash first.
No.
Mac users don't have C drive and D drive. Mac users just have, I don't know. There's still a file path structure, but you don't use C:, I'm pretty sure.
And then how do we know if we found it or not?
Oh, what was the document? Universal Bank Data?
Yeah, .csv. You gotta make sure you have the .csv in there. Let me move this over a little bit. How are we doing?
And then what name stat is part of that line, or no? Second one.
Names just shows these names down here. So when I highlighted both of these rows, I read in the data and I looked at the names of the variables. That's more for me to just, it's kind of like a check, you know, just to see what I got.
So then how can we check if it's right?
Well, one way to check if it's right is to look over here. Do you have 2,500 observations of 15 variables?
So far, I've just written in the stuff, I can click any buttons, I don't know what button to click.
Don't forget that at the end of the row, when you have the read command, you got to execute it. So Control-Enter.
So I
You don't actually have to put your mouse at the end of the row, Jacob. You can put it anywhere on the row you want, hit Control-Enter, and it will run the command.
Okay, good.
Did it run?
I think so, yeah.
If it, on the bottom, if it doesn't give you any error down here,
I got some blue stuff.
yeah, if you just get a cursor back.
Right. But I didn't get all that stuff that you've got. I just got.
Let's I think we're right.
I got this shit.
Yeah.
Mine has a 1.
For execution.
Yeah, so you should see the data set up there. You should see the data set up there. You should see when you run it, right? It should show you there's nothing, no error. So you're good. I can take it.
Good.
Good? Both of you guys? Okay.
Go to this line.
Gemma, you good? Okay.
Control click that one.
Perfect.
Why are they 6?
Yeah, I don't.
Yeah.
Ahmed?
I just realized that on the other, this old stuff is I thought there was a video of garbage.
Oh,
Now we're kind of just.
All right. How about you, Mike?
Struggling.
You have the data?
No, nothing. I need to log on again with the blackboard.
Yes.
RStudio.
I think so. I don't have all the stuff that he's got. But some of it. So.
You have the in the right.
Okay, so open RStudio, do you have a...
Download this one.
Okay, so
one for
the third one is the one for execution.
But if I click on it, it opens in the browser. So
Okay.
this is the effect on
Okay, well, we can... Where is it?
My friend was saying she's watching a DVD with her girlfriend. I'm like, how old? When's the last time you watched DVD?
Me?
Yeah.
Before I got
Okay.
here.
Yeah, I watched DVD for ages.
Open it,
I don't even have anything to play it.
Yeah, same.
Okay,
It's great.
just
Then we can
click on it. Do Command
Just
A.
got these things.
Command A.
What is it?
USB Type C.
I'm sorry, Command A, not Command E. Command A.
Oh, I thought that
Okay, now do Command C.
type of.
And Command C.
No. This
Okay,
is a
now you
standard.
copied it. Now go back to RStudio.
This is going to use standard computers.
It's not the same thing as the chargers.
This icon right here, you can see. Okay, make it big so we can see it. All right, hit File, New File, RScript. Okay, now you're there. You're in that window. Hit Command C. There you go. Now you have all those commands. You just copy them of the other file. Now go to the top
They're really close.
of this window. Back to the top.
Here.
I think what's happening is it's not scrolling for some reason.
So this is what we.
Is there a sideways scroll? Oh yeah, you tried it. Go all the way up to the top.
And this is what it looks like.
Okay, so this is the command you need to find the path. See, that's my path, right? And wherever your universal base is, you need to
So
read it.
basically, this is like your printing command.
Maybe Mike can,
And
maybe
then
Mike
this is
can
like
help.
showing you the
This is just his.
or whatever you say.
How are you doing?
Yeah, so let's say somebody goes just command these type of system. It's not like a beautiful graphical interface.
Yeah.
You can read everything from the file, you just have to do it really ugly, you know? Look at every line by line.
This is like computers nice to create.
It's like, yeah, you have to like indentation, pictures, subtables in your head.
The data is in the wrong place.
It's like Linux, Unix, old ass computing,
Linux is just the basic.
server stuff.
Go over to the untitled.
Well, you can do things with commands.
I think Mac OS.
Let's go back to, where's the blackboard? Here?
Yeah.
How do you get the command line thing up?
On what? On it? I have no idea. On here, you just do CMD, enter. Well, because CMD on Windows means command prompt.
Okay, now you have it there.
What's it called? Command line?
Command prompt.
Right, let's do this, let's do names. Oh, you don't have it in as dat. You still need to read them in. Here, let's try that.
Utilities folder.
Okay.
I
How
thought
about
that stuff
desktop?
was, like,
What's your,
supposed to be-
you know the path to your desktop?
I'll give it to you.
Okay, just type it in there. See, it says users, Cambridge.
Oh,
Ooh.
That's fine, or the.
Yeah, the tabs are file.
what can I do in here?
Yeah, copy that whole, okay, yes, so.
What would you
copy
call
that.
commands prompts for Mac?
You know, go back to R.
What would you want?
I don't know. I don't know what
Now
to
paste
do.
it over,
Here.
yeah, paste it over there, and we'll see, not the whole thing, be careful, leave the university.
Do you use that?
Only for some
Here's what we
things.
got, we got.
Like troubleshooting, like it's not super common. There's like some programs that I've never installed that I can install. And so what I do is like open commands.
Did it work?
Now
You have
to
DAC up there in the
whatever
right-hand corner?
running file to do.
Or did it give you there?
You know,
It gave you there.
permissions.
Down here,
I
it
don't
says
know why
something.
some things only install it. It's like they don't play well with the user interface.
Okay,
Typing save with my text input.
alright, now just hit control, and you don't even need
Do you
to.
know how to get it to shut back off? Is that
Save,
good enough?
and then in quotation marks.
I don't know if help you on
Hello, Erica.
It worked, that.
Okay, so what do we do now?
Okay, so, alright, so I think everybody except for maybe Michael has the data now. Michael's close.
Oh, stay.
All right, so remember, anytime you run a command, right, you have to hit control in the upper left-hand scripting window, you have to hit control enter, okay? So or it's probably command enter on a Mac, right?
I've been using control.
Okay,
Maybe that's it.
maybe either one works.
Maybe command.
All right, this names command, all it does is tell you the names of the variables. Okay, so we have the same variables that we had before. There's 15 variables, there's 2,500 rows. All right, you see that?
I have the data set visible.
Yeah, I don't know what that is. It's like a viewer or something. I never use that. Okay.
So do I work in the console? Or?
No, you work in the upper left-hand scripting window.
One more stupid question for you.
Yes.
Not that it matters, but in that global environment top right, I still have all the crap from the last time. Do I?
Oh yeah, so just do this, Erica. So you have all the crap from the last time. Use the broom,
Okay.
sweep it.
Sweep it out.
So if I sweep it, it's going to remove all the objects. And guess what? I can just do Control Enter again and read it right back in.
Perfect. Thank you.
Okay? That's a good idea because sometimes you have objects with the same names. So, okay? All right. Well, that must be one tricky menu path there.
No, we were struggling because the script was loading in R, not in RStudio.
Oh.
The file was
Just do Control A and copy it and paste it. All right. So if you run the commands on lines 11 through 13, the way you can do that is just highlight this like this, and you can run them all at the same time.
By control enter.
Yeah, again by Control Enter.
No.
Right?
11.
It basically summarizes. So notice the Y variable is called personal.known, right? So it just summarizes that we have 2,500 observations, about 10% of our customers, a little over 10% of our customers, right? So what it did on 11 was it took the average of ones and zeros, right? You take the average of 2,500 ones and zeros, right? You get a fraction, right? It's like 0 plus 0 plus 0 plus 1 plus 0 plus 1 plus 0 plus 0 plus 0 plus 0 divided by 2,500, right? About 10% of the customers took the loan offer, right? About 10%. Okay? So 2,244 did not, 256 did. Okay? So that's what we got so far. Okay? The next set of commands on lines 16 through 18, all that this is doing, let's look at 16 and 17. We've gone over this a couple times. Actually, the only key important line is line 17, but let's run line 16 first. Okay? This shows us the names in our data set. Now, this is just kind of data manipulation stuff, but remember, this is our Y variable, 15. The ID number of the customer is not going to be useful. So we're going to throw away column 1. We don't need it. The other thing is you don't need the education level variable that's 1, 2, or 3, and the indicator for education level 1, and the indicator for education level 2. You don't need this variable, basically. You should use these two. So we're going to get rid of variable number 7 also. All right? So on line 17, you can see what I'm doing. I'm getting rid of variable 1. I'm keeping variables 2 through 6. I'm getting rid of variable 7, and I'm keeping 8 through 15. And I'm creating a new object called dat1.
So we run line 17.
Yeah.
Okay,
So run line 17, Control Enter.
Names down.
Okay?
Yeah.
Right? And if you want to check what you got, you can, let's check the first 10 rows of dat1, just to see what we got. Remember the syntax here, it's rows and columns, rows, comma, columns, so 1 through 10, comma, blank.
Why is it comma blank?
Blank means look at all the columns, okay? If you don't give it an argument, it looks at everything.
I had 140, you changed it.
I changed it.
Right? And you leave the comma behind 10.
Yeah. Okay, let's see where we are. You have the data? Perfect. Do a sweep there. Hit that sweep button. That will work. So we can say yes. Okay, now read the data in one more time. Where's the command? It's the read command. Where is it? Yes.
I'm saying.
Just hit and go on.
What are
Oh,
these?
Give me a ping pong ball, what you want to do?
perfect. That way you don't get it. The only next command you want to run is line 18. Okay, so and then your file, like we're in the same place we are. Okay, so basically what we got now is we got another object called dat1. And you can see it over here, it's got 13 variables, not 15. That's because we got rid of 2 columns we didn't want to work with. All right? So that's the whole thing there. All right. Let's see if we can use this package called class. All right? Oh, let's do this. It says first we will run k-nearest neighbor. Okay, so I guess we're going to run k-nearest neighbor first. Let's see, maybe not. Let's skip that part. All right. Okay, so what are we doing here on lines 35 and 36? I'm going to have to rewrite these notes when I give them back to you as completed, right? All right, so I'm going to define 2 more objects. Again, they're called data frames, right? I'm going to take the subset of the rows of dat1 that are successes. Remember, in the 13th column of dat1, this is the 13th column. That's whether or not they took the personal loan. 1 means they did, 0 means they didn't. The first command there is going to say all the rows of dat1 where this 13th row equals 1. And the second one is going to take all the rows of dat1 where the 13th column equals 0. So you can see that syntax. It's kind of like an if statement there, right? So let's run those 2 rows.
So highlighting those.
And you get 2 more variables, 2 more data frames with the same number of variables. One that has all the failures in it. So you've basically done the following. Let's see if I can use this without blocking the view. Right? Remember, we had 2,500 rows, right, in our data set. We've now broken it into 2244, where the y variable is 0 all the way down, and 256, where the y variable is 1 all the way down. Okay? So that's what we've done on those 2 commands. This one's called fail, and this one's called success. Yes. Not sucker, but success, right?
Sorry about that, I was dealing with nothing.
Oh yeah, so after, just run line, is it 18?
35, 36.
No, before that though, we ran
17.
We ran line 17, Michael. Line 17, yes.
And then 18.
Just 17. That's the line you have to run. Okay? That sets up the dat1 object. Okay, then you can run 35 and 36.
And how did you display the field in the console or the rows?
That's line 18. Yeah. All right. Okay, so this is tricky here. So the next set of lines, 40 and 41, we're going to start setting up our training data set. And the way we're going to do it is, out of this 256, we're going to take a random sample of 128. So we're not going to just pick the first 128, we're going to take a random sample. So what this thing does is it says, take a random sample out of 1 to 256 and take a random sample out of 1 to 2244 of size 128. Okay, so there's things like this that this thing runs very quickly. So watch what happens when I run this. It seems like nothing. If you want on line 42, you can say, what's inside this train.success thing? And I'm just going to look at the first 20 numbers there, 1 through 20. Okay? Your numbers are going to be different from my numbers, so don't stress out about that. It's no big deal. Your answers are going to be different because we're now taking 128 of these and 128 of these, and we're going to make our training data set out of that, right?
What did you do to those numbers?
Which numbers?
This change the graphics.
Oh, I just typed in I typed in on line 42, train.success, 1:20.
Is this really a count?
No, So what we're saying is, look, we're taking, out of those 256, the very first one we're going to grab is row 212. Then we're going to grab row 209, then we're going to grab row 52, then we're going to grab row 140, then we're going to grab row 44, and so on. There's no duplicates in this list. And this whole list is 128 things long. Okay, so you see how fast it does this stuff, right? We took a random sample out of 256 of size 128 without replacement. Okay? Okay? And it did the same thing for this 2244. Okay? Now we haven't finished building the training data set yet. You have to go down a little bit further. Okay? And the training data set is going to be finished on line 49. So if you hit Control Enter on 49, oh shit. Okay? You will notice that you now have a thing called dat.train, which is 256 observations on 13 variables. And in this set, remember, there's exactly 128 ones. There's exactly 128 rows with ones and exactly 128 rows with zeros. 128 and 128. So this object is called dat.train. And that'll be the data we'll use to build our model. Okay? Now, I kind of lied to you in the presentation before, and without getting into the details, I'll do it for you in the answers, but because I want to get to the modeling part, we'll do this. The test data, the other data set. Remember, I said we're going to do exactly 1250, right? It's going to be the test data set. Let's call it dat.test, right? Well, the way I did this was this little minus sign here kind of indicates take the rows that are not up here, take the rows that are not up here and put them in. So basically what I'm doing is I'm taking everything else from here and everything else from here. So everything else and everything else. So basically all the data that I did not use in my training data set becomes part of my test data set. So that means my test data set is going to be what? 2500 minus 256. That would be 2244 rows. So I said it was going to be 1250. It's actually going to be 2244. The reason I don't want to go through that now is there's a few more logic steps we have to go through, and it's going to be too boring, so we're not going to do it. All right? So I'm going to run line 52. So now you see I've got a training data set, 244, and a training data set, 256, and a test data set, 244. So remember the process. The important process is we're going to use this data to build a good model for predicting whether the customer is going to take the offer or not, and we're going to test it on this other data set, see how well it performs. Okay? So the first thing we have to do is build the model. Okay? By the way, if you want to just run 54 through 57, you'll be able to sort of a verification step. Okay? On 54 through 57, we create a little table. This shows that in the training data, 128 zeros and 128 ones, and it shows that in the test data, the other 128 ones and all the rest of the zeros, right? So I lied about this part, sorry.
Ours are both popping errors for that whole.
Okay. Do you have? Did you run line 50? Did you run line 50?
No.
Run line 50. We ran line 50. You might have missed that.
And
then run 54.
We actually did 40.
Yeah. So what happens is you'll get an error because it's looking at this object and doesn't see it's not created. So you get an error. Okay. That worked.
Yeah.
Okay, good. All right, let's get to some modeling here finally. Okay, so I'm skipping some lines. Again, I took this code from somewhere else. We're going to run line 76 and 77 next. All right, so what's happening here is this. Remember, you probably don't remember, but when we ran regression, we used LM in R. LM stands for linear model. Now we're going to run a logistic regression. The way you tell it it's a logistic regression, first of all, you can't use LM, you use general linear model. It's a bigger class of models. And we use the same sort of syntax. We tell it the y variable. So we're going to use the training data. We're going to use the y variable. There's a $sign in there. That's how you tell it. And you're going to regress that data against all the other variables in your data set. So tilde dot means use everything, all other, I think there's 12 other variables. Use all of those plus an intercept and try to predict the personal load, right? Actually, we can change one thing and it should still run. This is a little bit more wordy than it needs to be. I'm going to take out, just going to backspace and take out that, right? Because we don't need the data set there. Because I'm telling it what data to use over here, right? So that tells it the data to use, our training data. And then it has one more argument, family equals binomial in quotes. Again, you don't have to type anything, it's already in there for you. But that just tells it that we're running a logistic regression with, I think, with 2 groups. Pretty sure that's it, right? So if you run that, really exciting. I think I just ran it. Let me try again. Control Enter. Right? Really exciting. Nothing happens. But that's a good sign in R. It means you didn't F up. Right? Right? If you run the next line, you'll get the results.
Run the next.
So line 77, you'll get the results. Okay? So I'm going to kind of make my window big here so we can kind of look at the results. All right? So remember, it's that e to that big function over 1 plus e to that big function. Notice you don't ever see any of that, right? You see something that looks just like linear regression, okay? You've got slopes, right? These are those weights you were asking about, Jacob. You've got the intercept. You've got p-values, right? On the last column, you know you've got stars and dots, right? So you know it's significant, right? You don't get any R squared, which kind of sucks, right? R squared is such a great measure. There's no R squared. I don't know how much time you have to explain, but we do get this thing called null deviance and residual deviance, all right? Let me give you a little bit of an example. In regression, I'm going to hurt this beautiful fireplace. It's probably been here for thousands of years. Okay? In linear regression, we started with the sums of squares total, right, which is a measure of the variation in y. And then we moved to the sum of squared errors, which is a measure of the variation between y and y hat. Right? And this is what we call the leftover variation or unexplained. Leftover variance or unexplained variance. Y hat, of course, remember, is y hat I equals b0 plus b1 x1I plus b2 x2I and so on, right? So y hat is the forecasted value. This is the actual y. That's how far apart they are. And then we measured this r squared, which was just 1 minus SSE divided by SST. These formulas are also in the book in chapter 9. So unexplained over, right, so that's the percentage unexplained, so R squared is the percentage explained, right? Now we have null deviance, so the analog here is null deviance, right? Deviance in the null model, and over here we have residual deviance. So in some sense, the deviances, they're not the same as the sums of squares, but in some sense we started at a level. Deviance is a measure that comes from, basically, if you think about it, when we do regression, somehow we pick these slopes so that they're the best. And behind the scenes, what's going on is it's actually minimizing, it's an optimization problem, it's actually minimizing the SSE. That's what it's doing. Making the SSE as small as possible. It's picking these variables. You can actually do it in Solver if you want. It's picking these variables to minimize this equation. Okay? So Here, it's also doing an optimization. It's picking the slopes, these coefficients, right, to minimize the residual deviance. So they don't have the same interpretation, but one thing you can see is you started at 355 roughly, and you went down to 126. That seems like a pretty big drop, right? Also, you can see there are significant variables, and there's some that are highly significant. So things are going good for us, it looks like, more or less, right? We're probably doing okay in this model, okay? Right? Yeah, so before you get the picture, this is linear regression. Linear, right? And this is logistic down here. All right?
How do you know we're doing okay again?
Well, two ways. One, we have some significant variables. That makes me feel good. But two, the deviance went from 355 down to 126. So you're never going to get, you could create your own R-squared model, right? You could say, okay, let me look at 1 minus 126 divided by 355. So it's actually more like 127, right? You could say this is a measure, call it R-squared. It's really not R-squared, so you can't call it R-squared. Okay, so I put it in quotes. Pseudo R-squared. But it doesn't, it's not the same thing. All right?
So that's about 70%.
Yeah, it's pretty good. I mean, what I'd be worried about is, even if I had significant variables, if these numbers were very close together, it would mean that probably, even though they're significant, I'm not doing much in terms of explaining. But what this is showing me is that there was a pretty big drop here, at least in magnitude, so I'm feeling kind of good. All right? Let's see what our next step is now. Oh, so which variables look like they're important here? Which variables look like they're important?
The stars. Oh, the variables?
Yeah, the stars. So give me one that you think is important. Income. Okay? Income. Now, income has a positive coefficient, right? There's no negative sign there. So that means as you have more income, taking the loan is not less risky. We're predicting who took it and who didn't. It's more likely you're going to take the loan, right, if you have more income. Does that make sense? Could, right? It means you're more comfortable about being able to pay it back, maybe.
It actually doesn't, because if you have more income, then
right.
you don't have a need to take a loan.
Right, it may not, right, it may not, right? What else is significant? Education level 1, so the lowest educated group, right? What about education level 1?
So the less educated you are, the more likely you are to take.
Well, be careful, it's got a negative sign,
The more
right?
likely you won't take.
It's also an indicator variable. So if you're in education level 1 group, right, you are less likely to take this offer. And it is significant, right? Education level 2, on the other hand, doesn't look like it's significant, right? So remember, there's 3 levels of education here. So if you're education level 1, you're less likely to take the loan as compared to education level 3, basically, is what that's saying, right? Remember about the reference and all that kind of stuff? This is the kind of stuff, by the way, that will be on the quiz tomorrow, right? So we talked about indicator variables last week, right? So there's 3 education levels, 1, 2, and 3. 1 was the lowest, right? So what this says is education level 1 is less likely to take the loan as compared to education level 3, which is the reference group.
3R is the p-value?
This one's the p-value, right?
And the
So
higher,
remember, yeah, these ones are the p-values, right?
the higher, the less significant is the lower.
That's correct, right? Low PHO must go, right? Low, yeah.
Low thing.
Yeah, when P is low, HO must, I almost forgot my own saying. When P is low, HO must go, right? So, right? So that's the professional way of saying it, right? Leave the whole read out, right?
Sorry.
So, any other significant variables, highly significant variables?
Certificate of deposit.
Yeah, so if they have a CD account, right? They are highly likely to take the personal loan. It's kind of interesting, right? So a CD account means you have some money in a sort of savings account, right? You're also likely to take this personal loan. All right, so what you'd like to do is maybe shrink the model around a little bit, right? Let's see which way we're going to go here to make life easy.
I have a question.
Sure.
My data is different because it's random.
That's right, your coefficients are different, you have a different sample, you're probably kind of close, but it's probably not the exact same thing.
Yeah, the node and the residual deviances are the same, but the data is different.
Yeah, that's right, that's right.
Table.
That's right. But our models could be different, we could have even different significant variables in different situations. That's right, your numbers aren't going to be exactly the same. Alright, let's move down. Okay, so what we're doing here, how did we get these fitted values? Fitted dot values, where did it come from? Log red fitted values. Don't know if this is going to work. Let's see. Let's control. Oh, it does work. That is
Running line 18.
Oh, yes. So, this is one of the amazing things about R. Okay? Yeah, I just ran line 80. All right, let me explain to you what's going on. So, remember, in this, flipped it, so we have to flip it back. In this regression, we use the training data. We use these 256 data points. We randomly selected these rows from those successes and fails. The object logreg that we created on line 76 has all sorts of stuff inside of it, all sorts of things. In fact, if you look at logreg, if you're into data objects, it's called a list. A list in R is like a list of objects that are not all the same size. It's just a bunch of stuff, okay? One of the things inside of logreg are the fitted values, aka the Y hats. Remember we talked about the Y hats? And in this case, the Y hats are probabilities, remember? So this says that the 2,800, this says that the first row of fitted values, row number 1, is the 2,088 observation from these, I think, right? It has that, whatever observation it is, that person has a 99% chance of taking this loan offer based on that model. This is the Y hat. These are those probabilities, right? The second observation has a 94% chance. The third observation, 54, 95, 88, 82, right? They're all highly likely. I think the reason that they're all highly likely is all of our ones are on the top and all of our zeros are on the bottom. Let's check that real quick. We can do that by, instead of looking at 1 through 20, let's look at 120 through 140. Remember, there's 256. So after 128, they go to the other side, right? So here's 120, 130, 121, 122, 123, 124, 125, 126, 127, 128. Right? So the model's predicting most of these people have a high chance of taking the loan, right? They actually did take the loan, right? And it used this information to build the model, so that's all not surprising. When you get to 129, right here, all of a sudden, you're in the zeros now, right? Right? You're in the zeros. The 129th row was the first row of zeros. Now the model's predicting low probability of them taking the loan, right? Low probabilities.
It's regular numbers at the top.
Those are confusing. What they are is, remember, we took random samples of the 2248 and the 128, right? Or maybe these numbers correspond to the original 2500. That's probably what they correspond to. These rows are the original 2500. So in my sample, this observation, which is observation 120, was the 22nd 08 row of the very original matrix. I think you can ignore these. And yours are different than mine.
I have different numbers.
Yeah, and your probabilities are different too. Okay? But the important thing here is it looks like we're doing a pretty good job. It looks like most of the top ones look like they're probabilities that are pretty high. Most of the bottom ones look like they're pretty low. Let's see how well we actually did overall. Okay? So this is where that cutoff comes in. Remember I talked about that cutoff number? So here's what we're going to do. We're going to create a new object. You see the gets command on line 81. We're going to take the fitted values and we're going to put them into something called y hat, just so we can remember it easier. Okay, y hat based on the training data. Okay, so I run line 81, doesn't do anything, right? And then what I'm going to do is I'm going to say, if my probability, my y hat, is bigger than 0.5, this is like an if statement, like in Excel. If the y hat is bigger than 0.5, make it a 1, make it a person who's a good customer, who's going to take the loan. And if they're not bigger than 0.1, make them a 0. And I'm going to call that new object y.hat.train class, because we're going to classify the people, right? If you have a high probability, bigger than 0.5, you're going to be the good customers. If you're low probability, you're going to be in the bad customers, right? All right. So we run line 84. It runs. Let's just take a look at what we got. What you can see is for most of my first, again, looking at the first 20 data points, for most of my first 20, the model is predicting they're going to take the loan. Although we were wrong here on, what is this, 2019, 18 and 17, I was wrong on the prediction. Okay? And you could do this for all, if you want, you can do this for all 256. I'll do this for all 256. Real quick. Okay? So here's all 256. You can see at the first group, most of them took the loan. And then you get down to the last group, most of them did not. But there are mistakes too. Like this one on mine is wrong, right here. Alright? So the last step is to line 86 and 87, we're going to create the confusion matrix. Alright? Okay? Hopefully this will clarify. Okay? So did you run line 84?
Yeah.
Okay?
Yeah.
Let's try this. I think I know what happens. Okay, we got an error. We got an error. Alright, I know what the error is. Do you see, we have a little problem here. We don't have dat.train.y. We didn't have that object. We never set that up. We skipped a step higher up than we should have done. It's higher up than that, I think. It's on line, yeah, let's run line 61 through 64. Okay? Run line 61 through 64. We forgot to set something up. Okay, go back to line 61 through 64, run it. Okay? Now if we go back down to where we were, line 86 and 87. We got it. Now that's a very interesting matrix I got. Did you guys get the same matrix or is yours different? Close? Close but not the same, okay? I'm not surprised it's different. I'm surprised mine's symmetric. That's very surprising, okay? So what this says is these are my actuals across the top. So I had it backwards on the other board. These are my actuals, right? I had 128 people who didn't take the loan and 128 who did. These are my forecasts. Okay? So on both sides, I was right 117 times out of the 128. And I was wrong 11 times in both cases. I'm very surprised those numbers are the same. That just randomly happened. Okay?
It's the same. It's symmetrical line.
It is. That's weird. But it's not the same numbers?
No.
Okay. Weird. Well, you can see we're doing pretty good. We're doing at about 9% error or something, roughly, right? We got 22 wrong out of the whole 256. So I'm guessing it's roughly about 9% error, right? Remember, these are the ones that were zeros actually, and we predicted them to be zeros. These are the ones that were ones actually, and we predicted them to be ones. These are the ones that were ones actually, we predicted them to be zeros. So those are the ones we were wrong on, our model was wrong on, right? And by the way, we never simplified our model, okay? So all we've done so far is we've built a model on the training data, and we've seen how good we're doing, okay? And let's just do one more step on that. think there's one more step here.
So we can get the error percentage?
Yeah, that's 90 and 91. Okay, this is the ugly way of doing it. I'll show you the fast way of doing it. Okay?
Should I erase the
90 and 91. You can undo it by maybe Control Y or something. All right, I'll show you the fast way of doing it anyway. Okay, so what I did was on 90 and 91 was I added up these two numbers and I divided it by the total.
0.07.
And I got your number could be different than mine, right? But so far with the training data, we're getting roughly 8% wrong. 8, 9, 7.
I got 12.5.
12.5. Okay, yeah. So we're all in different places, right? That's because we all took different samples, right? The fast way of doing it, I'll do it on 92. Let me do it on 92. It's mean. Let me see if I can do this. Mean of dat dot train dot y equals dat y hat y dot hat.
Double equals?
I think it's double equal.
No, it's not double equal. I think it's double equal is when you use if, but now you are assigning the double equal.
Let's see. Yeah, no, that was right. It's 1 minus. Let me tell you what this command does. This, right? So it's 1 minus this. So this tells you take the average of the places where the training thing was equal to where the actual data, the training data set was equal to the y hat. Okay, take the average of those, right? And right, so those are all the ones that we're correct on, right? And then do 1 minus that, and it's going to come out with the same number when I run it again. I think that's the other way. Yeah. Okay. Again, you learn this by practicing. I'm not expecting you guys to learn this. All right. So here's the power of this thing. I mean, first of all, again, you can't do this in Excel without some other package, right? We've built this complicated model. We've made the forecast. We've looked at the y hats. We classified them as 1s and 0s. And then we saw we were wrong about 8% of the time. We're about 91% correct. At least in my case, you're somewhere around there, right? Let's see how well that model does on this data. Because that's the real test, right? Not how well did it do on the data that we used to build the model, but how well does it do on the validation or test data set. So it's literally one command, right? Here, y hat test is just using this predict command, the regression we already created, so that big model we were looking at, the test data, not the training data, so the second data set now, right? And of course, we're going to we have to make sure we let it know that we're doing prediction on a logistic regression. So that argument here, I don't know where these words came from, but that argument here just says, right? So it's like taking this, right? B0 plus B1x over 1 plus B0 plus B1x, plugging in the new x's from this test data set here, getting the y hats, right? But using the B0 and B1 from the model that was up above, right? And of course, we have more variables than that. So it's doing all of that in one command. Okay? So run that 94. And once you do that, you can run 95. And you can see here's the predictions, the probabilities. Again, this is on this new test data set. In fact, if you look over here, y hat test has 2,244 rows. Remember, our test data set now has 2,244 rows. This is 2,244.
There it is on the right side.
Yes, it says it, right? 2,244. Yep. Oh, I wrote it? Yes, 2,244. Yes, thank you. All right. Now we'll run through the same set of commands. I'm just going to do it all at once. So 98 through 101, do it all at once. Okay? And here's our results. Okay? So what I did was, again, I took any probability that's bigger than 0.5 in my test data set. I said, you're a good customer. Anybody who's not, is going to be a bad customer. I'm going to start classifying people, and then I built a little table. So the actuals are here. The forecasts are here. Uh-oh, I flipped that from last time. I apologize. Gotta be careful how you enter these arguments. Anyway, these are all the people who didn't take the loan. These are all the people who did take the loan. These are our forecasts going down here. That's why I put the white hat in the name, right? These are the corrects. These are the incorrects. So I'm thinking the error is going to be a little higher now. And I'm not surprised because this is a data set that I didn't build the model with. I built the model with this other data set, right? So I'm not surprised the error is going to be a little higher. I'm guessing on the next lines down, I'm calculating that. Yes, I am on 104 and 105, right? Not bad, though, right? The error didn't go up by too much. It went up to like 10% error, right? See, if the error had gone up a lot when I tested it on the new data, I would have said, you know, that model's not very robust, right? It's not going to work for me, really. But since the error, it went up a little, but it didn't go up very much at all. How about yours? Did yours go up?
Went down.
Yours actually went down. So going down is even better. But you wouldn't necessarily expect it to go down.
Mine was 8%, I was 13.
Okay. So it went up a little bit more than mine did. But it didn't go up to like 40 or something where you feel really worried. Everybody else the same, more or less? So it seems like we have a pretty robust model. We're not going to be right all the time, right? But we're not, right? I mean, here you can see there's about a 10%. You're wrong a little bit more than 10%. Here you're wrong actually 20%. But this is such a small number of observations that it's not affecting things very much. I'm surprised that's not a little higher. LR test. Yeah, that's the right. That's the right thing.
So if it is below the previous number,
It's even better. I mean, because you built the model on one set of data and you tested on another set and you found out the model even worked better on a new set. That's a really good sign, right? That's a really good sign. All right, so we'll take another break in a second, but just to round out this example, let's run the k-nearest neighbor just to see how well we do with that, and I'll show you how that works. That's back up higher. Okay, remember how I said there's all these libraries that do different things? We're going to try this now. On line 22, there's a library called classification. So to run k-nearest neighbor, you need this library. So once again, I'll say the incredible thing about R is that somebody wrote this library called class and contributed to the pool of R code, and now it's available to everybody. And I learned about it, myself just by playing around with things and using textbooks. I'm going to say Control Enter on that page. It's going to actually go out to the internet. You're going to see it down here. Grab that code, download it, and install it for me. Essentially, and it gives you some red writing. Only because it's sort of warning you, but it'll give you a good answer at the end of the day, right? That's the problem with the lab, by the way. The machines are locked down, so you can't install things like this. And then you have to do one more command to get it to work. Notice there's no quotes now, right? You do one more command, and all it's doing is warning me that the library was built with a different version of R than I'm currently using, but it doesn't have anything to do with it, okay? All right, so then, down here, we've already done all this. We've already done all this. In fact, on line 61 through 64 that we ran earlier, we set things up for k-nearest neighbor. So let me just draw a graphic of that real quick. Everybody good with this? I saw somebody take a picture. Let's just show you what happens. This is getting kind of messy. So you've got training, right? 256 rows. You've got test, a lot bigger, right? 2,244 rows. Test, right? You've got the y variable, right, which is 0, 1 in both cases. And you've got a bunch of x's. x1, I think x12, right? x1 up to x12, right? So all we're doing in 61 through 64 is breaking this into pieces. This, and this, breaking it into 4 pieces. And what we're going to do in k-nearest neighbor is we're going to give it this piece and this piece. That makes up that graph I drew of red, right? This piece here is the dimensions, right? When Jacob was asking, with more variables, is it more than 2 dimensions? Yep, it's going to be 12 dimensions. And this piece is whether the dots on there are red or green, right? And then the other thing we're going to give it is we're going to give it this piece, right? And these are going to be the blue observations where you're going to classify them either as red or green, right? And we're going to ignore this piece over here for now. All right, so let's do it. It's right here, okay? So the whole command, you can see, I mean, this is the thing that's amazing to me. To write this code in like a programming language it would take me a couple of weeks probably to get it to work right. You're calling this command KNN, and it's doing all this work for you without any kind of touching. And you can see I've got the training data X's, that's this part, right? I've got the test data X's, that's this part, right? I've got the training data Y's, that's this piece, right? And I'm telling it the value of K I want to try. Let's try K1 first. Right? You can actually write a loop. I teach my students to write a loop to try different values of K. Right? And we're going to put the results in an object called out. Okay? So just hit Control Enter. It runs it almost in 1 second. All right? And let's look at what's in out. So on line 68, I'm going to write a command out. Let me see what's in out. Mingle 1 through 30 for out. Okay? So all it's telling me is in these observations, 2244, how did it classify them? Did it put it in the zeros or did it put it in the ones? That's all it's telling me. So I don't know how close it was, Raphael. That's the thing it's not telling me. It's just telling me I put the first observation as a 1, I put the second observation as a 1, I put the third observation. And because we use K equal 1 in K nearest neighbor, only looking at is who are you closest to. That's it. It's not looking at anybody else.
So there's no relationship between what we're doing to the probabilities and the...
No. There's no probabilities, there's no sigmoid model, there's no regression built into it, there's no nothing. You don't actually have any understanding of how the X variables are affecting things. It's a strong weakness of K nearest neighbor. But what you have is a model that could be way more flexible than regression. So you have a good thing and you have a bad thing. Right? So in this next set of commands, I'm doing the same stuff we were doing before. I'm creating a confusion matrix. Okay, so for my 2244 observations, here's my confusion matrix. Now you know how to read this, right? This is what the model forecasted right here. This is what the actual data was, right? These are the corrects, these are the incorrects. And you can see I calculated the error. I'm wrong a lot more often now, 17% of the time than I was before. We had it at 10% before, so this model is not doing nearly as well. You want to run it again, you want to try it for a different value of K, go up here to line 67, change the K to 3, highlight all of 67 through 73, run it again for K equal 3.
What is the K doing again?
It's looking at the K nearest neighbors.
Oh, okay.
Okay, so with K equal 1, I'm just saying, you know, for this person, who do they look most like? Yeah, you look most like this customer. Okay, then I'm going to make you the same group as that customer, right? K equal 3, I'm looking at the 3 closest, right? You can change it to K equal 5, and you can see why you want to do a loop, right? You can change it to K equal 5, you can rerun it. Okay, it went down a little bit, that's promising. Let's look at K equals 7.
Can you do an even number?
You can, it'll still work, right? The problem with an even number is if you do 4, and if it's a tie between 2 and 2, it just randomly assigns you to one group or the other. So that's why we generally don't use even numbers. So you can see generally here, K nearest neighbor is underperforming this one.
Okay. The error is less if you put 7.
Well, yours might be.
Mine is not.
Yeah, mine's staying around 17% for all of them, right? I wouldn't want to be too precise with this because, remember, if we go back to the beginning and I rerun all those code of the sample I took and all that, I'm going to get different answers, right? So But what you're really seeing here is the power of, validating your model on a new data set, essentially, is what we're doing that's new. And of course, we're also doing classification, which is new.
What happens if you do k equals dot?
K equals what?
Dot, which is all.
I don't know. I think it's going to give you an error. Let's see.
It's not a value.
Yes, it doesn't know what dot is.
So some
What if
crazy,
you do like K
crazy
equals,
high number.
K equals concatenation of 1, 3, and 5. I never tried this. Yeah, it doesn't like that either, right? So I've gotten pretty used to the warning messages, right? Usually I can figure out what they mean. Try a high number, that's a good one. Like try K equal 21. Let's see. Oh, there you go. You did a lot better with K equal 21, right? All of a sudden. Oh, wait a minute. I'm not sure if that ran. I think I hit another command accidentally. I don't like all those crosses there. Where was I up here? Oh, I left off a parenthesis. See, it's giving me an error on every line after that. All right, let's try it again. Table 21. Yeah, it's not changing. It's not changing. It's not really changing. And one more thing I'll show you, I guess, because I can now. I should have shown you this before, but if we go back to the logistic regression, you might remember we talked about using different values for the cutoff. Let me run these lines again so you can see what I'm talking about.
8.5.
98 through 105.
Oh, it's less, the error is less.
Okay, 98 through 105, right? So maybe you want to alter your cutoff and you want to say, instead of 0.5, let's use, I only want to look at customers who have a 60% chance of buying. Let's see how that works. And there could be good economic reasons for this, right? Maybe customer acquisition is expensive, right? So when I look at 60%, my error actually went down, right? So that's possible, right? So now, but I think if you compare what we had to what we have now, let's see if we can do that. If we look at the tables. Yeah, now you can see them both, right? So when we raise the probability, let's see if I can say this right? So there's 128 here, and there's 128 here. We raised the bar for customers, right? So we were wrong less often before when we were trying 50% than when we were trying 60%. So now we're missing more customers who actually did take the loan by raising the probability. So that actually went up. But in terms of the zeros actually went down. So in some cases, being wrong on one side might be worse than being wrong on the other. So you might want to change this. In other words, if I'm looking for customers for these loan offers, maybe I want to cast a wider net. Because if I'm marketing to them via the internet or something and the cost for marketing per customer is really low, maybe I just want to throw out a pretty wide net. On the other hand, if the acquisition cost of a customer has to do with a lot of meetings personally with a customer or phone calls, or there's a lot of material you have to send them, or there's once you get a customer, there's a lot of processing fee and processing the customer through the process, then maybe you want to only look for customers that you're sure are going to take the loan. So there are reasons to adjust this, right? So what I'm pointing out here, though, is that we did better on these, the non-takers, but we did worse on these. The reason the probability dropped from 10 to 7% is because there's a lot more of these than there are of these, right? If it were more balanced, then that wouldn't have happened, right? In this case, maybe then you want to alter your probability in the other direction. Let's just see what happens. I'm sure the error is going to go up. We alter the probability in the other direction. Instead of 60, let's go down to 30 and just see what happens. Okay, yeah, now the error went up. But you can see of the customers, well, I don't know if we're doing that much better, right? Of the customers who, yeah, so in this case, we're now predicting a lot of customers are going to take the loan who actually didn't take the loan, right? So we're putting a big group of customers in the group, right? Right? But we're doing a pretty good job of screening out those who aren't going to take the loan, right? For those who aren't going to take the loan, we're predicting only 12 actually did take the loan who we predicted did not. So, but because there's so many more in this group, that error actually grew. All right, there's lots of other classification models. I think now is a good time to take a little break. There's lots of other classification models. If you want, what we could take, why don't we do this? Why don't we skip the part on the economic forecasting? We'll take a little break for a minute, and then we'll just do one more model that's kind of cool. It's called a decision tree model, or it's called a regression or classification tree model. And since we have a good board here, I can do it, and I can show you in R very easily how to do it. And it uses a different library. I'll just get ready and then do that.